Hello students, welcome to Engineering Graphics in Beyond Theory. In this section, we are going to discuss the orthographic projections of solids. And in this particular video, we'll be studying about the different types of solids that are available. And then we'll be identifying the positions of these solids with respect to HP and BP. So mainly in solids, we are having two types of solids that are prisms and pyramids. Prisms are solids whose base and top face are of same shape. Usually all solids are named after its base. Suppose we are having a prism whose base is a triangle in shape. In that case, this solid is called a triangular prism. Similarly, here you can see that the base is a square in shape. So this solid is called a square prism. Similarly, we are having a pentagonal prism, a hexagonal prism, a cylinder, and a cube. The common thing in all these things are the base and top face are exactly identical, and the base and top face are joined using vertical edges. Next type of solid that we are having are called pyramids. Pyramids are solids whose base are of some shape which are joined to a single point. Again, solids should be named after its base. So, suppose we are having a pyramid whose base is triangle in shape. So this solid is called a triangular pyramid. Similarly, the shape of the base is a square here. So this is called a square pyramid. Similarly, this is a pentagonal pyramid, hexagonal pyramid, cone, and a tetrahedron. The common thing in all these figures are its base is different, but all the corners of the base are joined to a single point. And the lines are inclined in nature. Next, we are going to know the different names and planes that are available in pyramids. Suppose we are having a square pyramid. This surface of the pyramid is called the base of the pyramid. The lines that form the base are called the base edges, and the lines converge together to form the corners of the pyramid. The lines that are starting from these corners are slanting in nature. So these edges are called as slant edges, and the faces that are formed by this slant edges are called triangular faces. You can see that all these slant edges are converging to a single point. This particular point is called the apex or the vertex of a pyramid. All solids are having an imaginary line that is passing through the center of that solid. That line is called the axis of the solid. It is usually represented using a chain line. Similarly, prisms are also having different edges and different faces. This surface of the prism is called the base of the prism. And this surface of the prism is called the top face of the prism. The lines that form the base are called the base edges, and the line that form the top face are called the top face edges. The base edges all are joined together to form the base corners of the prism, and similarly here we get the top face corners of the prism. Here you can see that the base and top face are joined using vertical lines. So these edges are called vertical edges, and the faces formed by these edges are rectangle in shape. So they are called rectangular faces. And again, this solid is also having an imaginary line passing through the center. It's called the axis of the solid. Next solid that we are having are the cone and the cylinder. They also come under a prism and a pyramid family. A cone is having its base in circular in shape, and all the surface of the base is converging to a single point, that is the apex or vertex. Similarly, cylinder comes under a prism family, and the base is converging, or it's forming the top face using the same shape. Common to cylinder and cone are it doesn't have any edges, but we feel that there are some lines on its surface. These lines are called the generators of a cone or cylinder. Next, we are going to represent these solids with respect to HP and VP. Suppose we are having a horizontal plane and vertical plane like this, and assume that we are having a prism that is resting on its base on HP. Now you can see that the axis of this solid is now perpendicular to HP and parallel to VP. Our aim is to draw the orthographic projection of the solid. That means we are going to draw the top view, front view and side view of the solid. Always we have to draw the base of the solid first. And here we can see that the axis of the solid is perpendicular to HP and parallel to VP. So from this, what we can understand is, if a solid is resting on its base on HP, its axis will be perpendicular to HP and parallel to VP. Now, when we are going to draw the orthographic projection, we have to draw the base of the solid first. And in this figure, we can see the base only in top view. So, whenever axis is perpendicular to HP and parallel to VP, we have to draw the top view first. Then only we will be able to draw the front view. Next, assume that we are having a solid that is resting in this manner. In the previous case, the solid was resting on its base on HP. Here we can say that the solid is resting on its base on VP. Or in another manner, we can say that it is resting on its rectangular face on HP. Here you can see that the axis is now perpendicular to VP and parallel to HP. So from this, we can understand whenever a solid is resting on its base on VP, its axis will be perpendicular to VP and parallel to HP. And when we are going to draw the orthographic projection of this solid, we will be able to view the base only in front view. So, whenever axis of a solid is perpendicular to VP and parallel to HP, we have to draw the front view of the solid first. Then only we will be able to draw the top view of the solid. And assume the solid is having a position like this. Here we can see that again the solid is resting on its rectangular face on HP. But you can see that the axis is now parallel to both HP and VP. Again, if we want to get the orthographic projection, we have to draw the base of the solid. And here, the base of the solid can be visible only from the side view. So, whenever the axis of a solid is parallel to both HP and VP, we have to draw the side view first. Then only we will be able to draw the top view and front view. So from this, what we can understand is, whenever axis of a solid is perpendicular to HP, we have to draw the top view of the solid first. Whenever axis of the solid is perpendicular to VP, we have to draw the front view first. And whenever axis of the solid is parallel to both HP and VP, we have to draw the end view first.